Okay, first step would be to build the capacitor bank. I'll be using 10 capacitors in parallel. Okay, the glue's holding up good. The temporary setup right here. I have my bridge rectifier in there, my capacitor bank. Here's the voltage. I have the motor running right now, my lathe motor, 41 volts. I have my oscilloscope set on 1 volt interval per division, and it looks like I'm hitting about maybe 0.2 volts with the motor running. 0.2 volts ripple, that's ripple voltage right there. Now I'm going to check it with a load. Here's the amount of load I'm putting on here, and we're going to check now the ripple voltage. There's the ripple voltage. This resistor right here is about 39 ohms, and it's a little over half a watt. I don't have no half-watt resistors for 39 ohms. I have them for all these resistance values, but I don't have it here. I have quarter-watt resistors only. So what I'm doing is I'm putting in parallel 330 ohm resistors, 8 of them in parallel, to give me about 41 ohms. Two 2.4 k ohm resistors in parallel to give me my 1.2 k ohm that I need for the base bias resistor of Q2. And those two resistors go to ground from the base of Q2, which is the feedback transistor. This is the ground connection here. This is the base of Q2 right here. try to get these here as close to the board as possible. Alrighty. Okay, the 470 ohm resistor is the supply for the Q2 base that connects to the output of the regulator series pass transistor. This is the 470 ohm resistor. Okay, this last resistor here is a 2.2 k ohm resistor. That's being used for biasing the 3 transistors that are configured as a Zener diode configuration. This is to give them some bias. It takes care of all the passive components as well as 3 active here, which is the diodes. But now it's time to put in the transistors. Okay, what I want to do is I want to be able to take the transistors out if I need to change them out for some reason. So that's why I designed this with a SIP socket, a single inline package socket here that I will use to use as a transistors thingamajigs, transistor things to hold the transistors sockets, so that I don't have to so I can change them out without having to desolder them if I burn up a transistor or something. I can just slide them right out of here. Come on. I get them past these resistors here. Make sure they go in nice and tight. And it looks to be running pretty good. These are the flyback diodes here across the motor, across the lobe, which would be the motor in this case. And I'm putting 2 there to help disperse the current between 2 of them instead of just using 1. And that helps eliminate any kind of kickback. When the motor shuts down, you have a little bit of a kickback on current that could go back into the circuit, and these diodes will flush that out and take it back to ground. Those 2 diodes right there, that's what prevents that inductive kickback from flowing back into the rest of the circuit. Alrighty, the last thing now would be the main transistor, the series pass transistor, and that's the power transistor. And that's going to come next, and then we'll flip these here transistors in here, and this acts as a transistor sockets now, so I can change these transistors out anytime I need to. Verifying what's the base and what's the terminals on this here transistor. Also making sure the transistor is operating properly, and it is. The bottom here is the base. It's NPN transistor. The bottom is the base. This is for the collector. to bolt onto. Okay, this is the base right here. The base goes down. That's the base. Goes down. Goes in this hole here and there. Slide in there. It'll sit on top of that nut to give it some support. And then put another nut on top of that to make connection. Now here I think I'm just going to bend these down because I don't want to ruin the leads on this transistor. Alright, I'll put these here transistors in down here now in their sockets, and then we'll give it a test. Start loading transistors now in their sockets. Now these are the three transistors that make up the Zener diode. They go collector, base, emitter. And the second one, collector, base, emitter. And the third one, collector, base, emitter. And that should give roughly about 24 volts, 23 to 24 volts Zener voltage, because they give close to 7 to 8 volts each one. Now the next transistor is going to be the feedback transistor. The feedback transistor goes the other direction, emitter, base, collector, so that the emitter of this last transistor feeds the emitter of this one. And then the last transistor of this here will be a PNP, and that will be the one that is used to bias the base of the series pass transistor. These first four are all NPN transistors. This is the PNP transistor. Now it goes in the other direction, collector, base, emitter. So the emitter of this, the collector of this one feeds the collector of this one here. Because it's a PNP transistor, its emitter goes to the positive side of the battery through this resistor arrangement here, which is close to about 40 some ohms. Okay, now we're going to go ahead and hook it up and see how that works for regulation. I got two more bolts yet. I have the this is the input, this will be the output, using 632 screws to make connection on the back side. And then this one will be the ground connection. And then I can put clips on there when I go to actually do the hookups. Come on. Nice and tight. Oh yeah, it's nice and tight without having a screwdriver. Alright, now let's go ahead and try it and see how it works with the supply and see if we get some regulation here. Okay, I want 38 volts coming in, so that will take these two wires here, AC. there's ground, and positive is the inside, and that would be the positive coming out of here, and then from here we go to there now. Okay, here's the ground right here, and this is the output. So we have the input coming in off of the unregulated supply, off of the capacitor bank, off of the bridge rectifier into here, and then we have the output coming out of here, and this is the ground. So now we'll check a voltage measurement here. Okay, so now the voltage, or the multimeter, hooked up to the output here. Turn that on. Let's plug it in and see if we get around 30-some volts. Alright, there it is. We're looking for 34 volts, and there it is, 34 volts. Let's do a check here real quick. The input coming in should be around 40-some volts. 42 volts coming in. Output, 34 volts output. Looks very good. Very good. I want to do before I call it quits for this evening, I want to plug my lathe in and see how it's regulating. Right now the lathe is turned on. Turn the right direction here. Okay, so the lathe is running nice, and I'm running around 34 volts, which is nice. I like that a lot because that means that the regulator is working properly. With the motor running, I'm still at 34 volts. Now I'm going to put a small load on the motor here a little bit. And oh, that's saying nice. That's nice. Right there. I just had belt slip just now and it only dropped to 32 volts. That regulator is working really good. Okay. I'm very satisfied with that, and that's all for now. Bye.